Okay, now we'll talk about the three types of operations you can perform with a laser cutter. These are vector cut, vector mark, and raster engrave. Vector cut and vector mark are very similar. The only difference is that vector cut refers to cutting all the way through a material, and vector mark refers to simply marking the material and not cutting all the way through it. This is accomplished by either lowering the laser power or increasing the travel speed of the laser. Raster engrave is the third type of operation and refers to engraving an image. Now, there's always a bit of confusion between vector marking and raster engraving, so I want to clarify that here. We'll start by discussing the difference between a vector file and a raster file. Vector files and raster files are two common types of digital image files, but they differ in how they store graphics. Vector files are defined by mathematical formulas. This formula describes where the line starts, where it ends, and the path it takes. A raster graphic, on the other hand, is defined by pixels instead of a mathematical formula. The laser cutter can follow the path of a vector line tracing the cut. It can't do this with a raster image. When engraving a raster image, the laser, instead of trying to follow a path, will rapidly scan back and forth, firing the laser where it sees pixels, varying the intensity of the laser based on the luminosity of the pixel. Darker pixels receive more laser energy than lighter ones. This will be easier to visualize using our example. The project we'll be making is a name tag that incorporates these three laser operations: vector cut, vector mark, and raster engrave. The text will be a raster operation, the inner rectangle a vector mark operation, and the circle and the outer rectangle a vector cut operation, since both these cuts will go all the way through the part. During the raster engrave operation, we see the laser moving rapidly back and forth as it engraves the text. During this operation, the laser is scanning back and forth and only firing where it sees pixels. Next, we go on to the vector mark operation, and you notice that instead of moving back and forth, the laser is able to follow the path of the rounded rectangle to trace the graphic. Since this is a vector mark operation, the laser doesn't cut all the way through, but instead only marks the surface of the material. And finally, we vector cut the circle and the outer rectangle. Notice that this is identical to the vector mark operation, with the only difference being that we slowed down the travel speed of the laser head. One way you can tell between a vector and a raster graphic is by reading the file extension. Vector files typically end with a .svg, DXF, PDF, AI, or DWG, and there are a few more, but these are the main ones. A raster or pixel-based graphic typically ends with a JPEG or a PNG. Another way to tell the difference is to zoom in on an image. Here inside Illustrator, if I zoom into our vector rectangle, we see that image quality does not change. If I bring in a raster or a pixel-based graphic, the more I zoom in, the more pixelated the image becomes. In order to create a vector file, you will need to use a software capable of designing vector graphics. In the makerspace, we have Adobe Illustrator installed on all the desktop computers, laptops, and iPads, as well as other design software capable of producing vector graphics, including Fusion 360, SketchUp, AutoCAD, and others. See the full list of available software on the laptop cabinet. A couple things to keep in mind when laser cutting. Always set your vector cut as the last operation. For example, if you need to engrave an image and vector cut it, you want to do the engraving first and then vector cut. This is because when you cut your shape, the material will drop slightly, shifting in position. If you engrave your material after it has shifted, it could throw off your alignment. Another thing to keep in mind is that when you're engraving an image, it's always better to orient your graphic in landscape orientation instead of portrait orientation. As you can see in this example, it significantly reduces your engraving time.